Hi everybody, this is Irikidzai Muchaneta, as you can see, Iki for short, and he's going to be talking to us today about some very cool things to do with computer vision. Take it away.
Okay, thanks a lot. Thanks a lot. Okay, so one of the things I'm going to be talking about is computer vision and audience response systems with regards to Python. So over the past couple of hundreds of years, technology has evolved as man has kind of used it. So people have used, can I call it, technology in various ways. In the middle, you've got a guy who uses sticks and stones, and then as we went through the Industrial Revolution, people kind of evolved with technology, and now we're at a point where we're using computers to practically solve all our problems. And that's how kind of we have evolved. So the next tool that I'm going to be looking at right now is computer vision. And this is what my talk is going to be based mainly on. And as you know, this is going to be the aim of my talk. Okay, so I'm going to talk on a few things. The first thing I'm going to do is I'm going to define what computer vision is. I'm going to look at audience response systems, ARS for short. I'm going to look at the motivation behind these audience response systems. Then I'm going to kind of look at the Python code involved. I'm going to kind of conclude and give a summary, and then kind of open the floor for questions and answers. Okay, so the first point that I'm going to actually look at is I'm going to define computer vision. So I know a lot of you are wondering, what is computer vision? And it's a question I get asked a lot every time I kind of tell people, hey guys, guess what? I'm studying computer vision. And it's kind of a study, it's a science. And it really looks at how can we get a computer to understand images? How can we get a computer to see images, read them, and understand and interpret them? So imagine, for example, you've got a cat. It's got whiskers, it's got eyes, and it's a nice furry color. So a computer can pick this up, it can see it, done. But now, what if you've got a lion? A lion is essentially a cat, but is it a domestic cat, or is it a totally different being? You know what I mean? If you say, hey, by the way, this is a lion, by the way, the reaction is to pet it. Or this is a cat, the reaction is to pet it. Is it the same? Maybe, maybe not. Then what if you've got a cat that's in a sink? You know what I mean? By the way, we can't see its legs anymore. We can only see its head, its back, and it's done. What if we've got a cat that is also in, for example, in a bit of trouble? Now, what we want to do is we want to allow computers to view this and actually take it. And it's a really new kind of field of study, because right now we can't get computers to actually take in this information. And if you kind of look at infants, when they're, I think, 3 years old, they'll be able to tell you that's a cat. If it's a cat that's lying down, they'll be able to tell you that's a cat. If it's a different kind of cat, they'll be able to tell you, hey, that's a real different kind of cat. Okay, so I'm going to be looking at some of the examples of the application of computer vision. So it really broads over a large spectrum, starting with your basic algorithms of computer vision, all the way to complex multidimensional algorithms. So on the basic level, you're really looking at number plate recognition systems, because the kind of computational, can I call it, power that's needed is not as great. Then we kind of move on the continuum to facial recognition, i.e. the ones that are used by Facebook, and then we move to your self-driving cars. This is what Google has decided to embark on. So with all these technologies and this entire spectrum, what you're really looking at is the different algorithms, the different tools, the different kind of complexities within it. First, I'm going to talk about number plate recognition. Here, the primary purpose is really detecting an area of focus, and that's usually where the number plate is. It's usually white in color, pretty chilled, and easy to detect. Then you're really recognizing the letters. So in this space, what are we looking at? We're looking for letters. Once we recognize these letters, we can write them to a file, and one unlucky person gets sent a ticket, and yeah, they've got to pay quite a lot of money. When it comes to facial recognition, it's a little more complex. It's not just about recognizing, but it's now about actually giving back and, can I call it, equaling a specific face. So you're looking at creating many negatives, and it's a Viola-type Jones type of algorithms, and you're looking at many positives. And you're now saying, by the way, in order to recognize a face, we're going to say negatives, positives, then you kind of recognize it. Self-driving cars, this is really complex. There's layers on layers of computer vision and different technology involved. First, you've got the training of a computer to know what image is which. Then you've got the sonar, which sends kind of like your infrared rays to kind of map the entire kind of world. And then you've now got to give this instruction, and then it's going to kind of look at what is what, stop a car, start a car. The second point I'm going to look at is an audience response system. And what an audience and also people kind of ask me, what is an audience response system? Now, what an audience response system is really trying to get feedback from the audience. That's what you're really looking at. You're looking at, hey, I would like to know, do people like this or not? And one of the definitions, I'm just going to read it out, is audience response systems are feedback systems that give a facilitator, like me, accurate feedback with regards to a large group of responses from a question posed to the audience. So imagine this, back in the day before computers were even there, how people used to feedback or give audience or give their feedback was all they'll do is raise their hand. Hey, by the way, what's the answer to this? I'll raise my hand. Half the class says yes, half the class says no. Now, what if you increase the number of people? Instead of 10 people, you've got 20. Instead of 20, you've got 200. And now it becomes really difficult to kind of view from the audience what answer is what. How many said yes, how many said no, how many said, guess what, when it comes to the race, I'm white, I'm black, I'm colored, the works. Now, Cadwell did a study, and he kind of looked at the benefits of audience response system. And what he saw was grades generally increase, attention span increases with the application of this audience response system. There are a few cons involved. For example, people are reluctant to contribute. Other people want to just stay there. There's a change in type of questions that you have to ask when you're asking certain questions and the works. And generally, it costs a lot more to actually implement this. And most of the time, lots of people don't want to spend the money or don't want to spend the extra kind of effort to actually get these audience response systems up and running. So this brings us really to the point of why would we even do this? And this is the motivation behind studying computer vision or studying audience response systems. And that's my third point. So the motivation behind this is, hey, if we can get the benefits, control the costs, then we're actually good. So imagine there's a lecturer kind of giving a lecture, and he asks a certain question on a board. I know a lot of people are generally either daydreaming, thinking about the next thing, or totally in their own world. And this is generally what happens. You know, I mean, lots of people are kind of looking at the time, thinking, hey, when is this talk going to end? Very, can I call it, accepted, I guess. So one of the questions that researchers asked is, as we gaze out of the sea of slouching bodies and expressionless faces from our podiums, it's hard to resist wondering if students want less education and more entertainment or what. And that's a nice quote by Carlin in 2004. And this is really what we want to answer and what we want to achieve. So what are the options in order to achieve this via computer vision or any other kind of technology? So we've got a toolbox. This is our problem. We need to find a solution. What we're going to use is technology. Pretty cool. Okay, so one of the things you can use is you can use a cloud kind of service. Everyone logs on their laptops, gives their feedbacks off laptop, it's get recorded, and yeah, you've got your answers. Awesome, applies to 200 people and the works. One thing you'll definitely need is a Wi-Fi, so that you're not excluding people. One of the other systems that was created quite a while back was clickers. I think everyone knows what a clicker is. You can kind of give a quick response. You just click a button, is it A, is it B, and the works. And I think clicker technology really started, I think in the 1960s at the University of Stanford. I think they started applying this in their universities. Stanford has got a lot more money than University of Cape Town, for example, and that's really where they started coming up with this audience response system kind of behavior. The next option or the next tool that we can actually use are cell phones. By the way, what if we have an app? We use this app to kind of get the feedback back, and then we're happy. I mean, the one thing that people need for that is smartphones. Sometimes in Africa, not everyone has smartphones, and therefore we can also kind of evolve back down to, can I call it SMSs? Okay, if you don't have a smartphone, at least you've got a phone. Not really the case. Here you've also got like an app that was created called SurveyMonkey. Nice app, it gives the feedback, everyone can kind of use it. Or we can kind of resolve back to how we used to do things back in the day. Raise your arm if you want to answer. But as we saw, large group of people, large kind of audience, and you really don't get to that point. So the one thing that we saw is the number of options depends really with the pros and the cons. So for example, as you can see, in my first column, I've got clickers, for example. And then I've got smartphones as an alternative. I've got the SMSs. Fiducial markers are kind of like a audience response system where someone holds up a card, it's got a little QR code, and then you can kind of pick it from there. And then one of the research points that I'm working on is image poll sheets. So also a kind of a computer vision technology. You hold up a poll sheet, it actually just takes a picture of it, and then you've got your answers. So when you kind of look at the maximum class levels, for clickers, smartphones, SMSs, it's generally 1,000 plus. I mean, as long as you've got a class, as long as someone has got a smartphone, a clicker, or can use SMSs, they can really send what they want. Now, with regards to these audiences, with regards to computer vision, what you're really looking at is your scope is really limited. And lots of studies have been done with a class of, let's say, 25, like the fiducial markers. Usually a guy says, hey, by the way, I'd like to research this. All I'm going to do is take a class of 25, and then it's giving me semi-accurate results. And that's one of the issues with computer vision is it's really hard if someone decides to hold their marker in a different way in comparison to the ideal method of, hey, marker up high. So when it comes to the accuracy, as you can see, clickers and smartphones and SMSs, I think, are 90 to 100. Something always happens. I think from research, people have seen that it's about 90 to 100%. You'll always get those odd few, hey, I didn't have airtime, or I don't know, the message got lost somewhere in hyperspace. When we looked at image poll sheets, we got about 85% out of a class of, let's say, about 250 people. So yes, it is pretty high, but when you compare it to clickers and smartphones, a little low. Then we kind of looked at the cost. Now, clickers, for example, cost anything between 200, and that's US dollars, and the low-end ones can be about 30 to 50 US dollars per clicker. So you're now actually looking at it, and you're now looking at the African demographic. And you're saying, can universities afford this? Yes, no, some universities can. As the number of universities grows, or as the number of students grow, we're looking at, let's say, 10,000 pupils. And now you're looking at 50 per clicker times 10,000 students. Yeah, the cost dramatically increases. SMSs, as you know, depending on the answers, the more answers you give, the more your cost rises, and then the works. So what I ended up settling down is on these image poll sheets. Awesome for Africa. Very cheap to kind of make, and easy to maintain. So that's kind of what I was kind of looking to when I kind of did the research on image poll sheets. So the real question now becomes, what's best for Africa? And what are the options that are best for Africa? Africa is different in terms of what it requires, what it needs, and what works best for it in comparison to all the other continents and the works. Okay, so I ended up settling on color poll sheets. I think I'm not too sure if any one of you understand it. So it's just a poll sheet, white piece of paper. You can just hold it up. Doesn't have to be that big, and it's got a color in between. Either it can be blue, or it can be red, or it can be green, whatever kind of answer you want to give. So usually you'll have it as one poll sheet with different sides with the same color, or different colors. One will be green, one will be red. And I can ask someone simply, hey, how many people think the sky is blue. Ray is blue if you want. And then this is a way of voting to say, hey, by the way, this is my answer. So one of the questions that maybe you might think, hey, by the way, can it work, is who invented Python, for example? And these are your options. You kind of give an option. Was it James Gosling? Was it Guido van Rossum? Was it Tim Berners-Lee? And now that's something I might ask the audience in per se. For example, let's show of hands what what the general audience would think the answer to this question is. Who invented Python? So I know people don't want to raise their hands, but let's kind of have a view. So let's say James Gosling. How many people think that's the person who invented Python? This is the Python conference, by the way. Okay, so no one thinks it. Okay. Guido van Rossum. How many people think it's him? Okay, we've got a nice show of hands. What about Tim Berners-Lee? How many people think he invented Python? Okay. Nice. So we've got a kind of an answer. And as you can see, you can't get the answer all at once. But with a poll sheet, everyone can kind of give their answer all at once, and you can kind of create a pie graph or a bar chart with the data you extract back from people. And this is all at once. It's done, and you get that visual feedback that you actually need. If you want, you can actually pull this into a database and kind of have these results of, the answers people are giving. So, yes, I've been talking a lot. So where are we? So firstly, I've defined computer vision, what it is, what it's about. So we can put a nice tick on there. Then the next thing I wanted to talk about was what is an audience response system that we've been able to cover. It's a feedback system that can be used in lectures or the works. The next thing, if you'd already forgotten, was the motivation behind why we actually want to study this, why we want to actually create something like an audience response system. So once again, tick for that one. So the next thing that we want to talk about is the Python code involved. So, and some of the challenges that I kind of faced whilst doing this presentation, actually the research, and then we're going to look at conclusion and a bit of Q&A. So right now, I'm actually going to go into Python IDE and actually look at what's it called? The Python code that I kind of used. And as you can see, okay, everyone can see it. Awesome. So I'm going to scroll all the way up. It's quite a lot of lines of code, but yeah, I'm not the best coder. So if you find something like too many if statements or loops, then yeah, forgive me for that. Okay, so I imported a couple of, can I call it libraries? I used OpenCV. So that's one of the libraries I used. So I also had it running off a Raspberry Pi. So in order to reduce costs, what I would do is put it on a Raspberry Pi, and then a Raspberry Pi can be somewhere in the front of the class, and after I ask a question, take a nice photograph of the class with everyone holding up their, can I call it their responses, and then I've got my answer. So a Raspberry Pi costs, I think, less than 1,000 now. I think when I got mine, it was pretty, I would think 1,500 Rand. But yeah, it's one of the small tools, and it's easy to maintain. So one of the things that I always like to do is I always like to record how long it takes. For my code in general, it actually did take quite a long time, which is also one of the challenges that I faced, kind of trying to reduce the amount of time. Because for an audience response system, what you really want is for you to ask a question, the audience gives you feedback, you take a picture, and automatically the audience can see the feedback of how many people voted yay, nay, or other, and then automatically you can kind of investigate that question, for example. So all I really did was imported the image. One of the issues that I also had, which was a challenge, was resizing. So the bigger the image, the longer it takes to kind of compute through the entire image. So one of the issues I had was, should I resize the image or not? And if you want to get better results, the best thing to do is not resize the image. So the code was there. I ended up commenting it out for better accuracy, can I say. When I'm going through the code, one of the things I would do is just see if I can see the image. And then the real algorithm to this code was really looking at the steps to take to kind of go get from a point of, here's the image, now let me read it, interpret it, and kind of gather the data out of it. However, one of the things that I wanted to do at the very end of the code is look and see how accurate was my code. So what I did originally was I took a picture that I had taken of the entire crowd. I manually had to mark, guess what, here's a point, it's correct, here's a point, it's correct. And that's kind of the research that I went through. So this entire section here is really plotting out the points where the audience really has responded, just to kind of have a view of what's a false positive, what's a true positive, what's a false negative, and the works. And you really compute it once you've kind of got this. I could have put that in a different file and then imported it into the code, but I kind of wanted it everything at one kind of area. The next thing I did in order to kind of move with the computer vision was to scale the template. So I don't think I mentioned I was kind of using template matching. So have a picture of the template or what I expect from the crowd, and then use this whilst computing or in my computer vision. So the first thing I would do, because there's one person right in the front of the class and they're holding the same size poll sheet, and there's someone all the way at the back of the class and they're holding the same poll sheet, obviously it's going to give you different sizes. So what I kind of did was start from a small template and increase the template scale by scale, and then you get to a point where you can detect someone all the way at the bottom and all the way at the top. So that's kind of the thinking I was going through when it came to resizing this template and running it through the picture. Okay, I went through one of the other issues you kind of always have is another person holding a template a little different to how it's probably supposed to be held. So for example, if I'm supposed to hold this in this way, you always get someone who decides to hold it like that, someone with a slight angle, someone totally the opposite way. So the one thing I would do after resizing it is to change the, can I call it the rotation? So run a rotation on my algorithm to first pick up size, then on a specific size, then I want to pick up rotation. Okay, yes, I picked you, it's big. Then are you holding it a different way? Then I'm going to kind of run a template on the rotation of your image. The next thing, and this is one of the most difficult bits, is the transformations that happen with computer vision. So yes, I'm taking a picture, but not everyone holds their image in a specific, can I call it 2D kind of view. So someone will always have it at a slight angle or skewness. And this is one of the transformations that once you look at the image, you would see that when it's trying to pick, anything that's skew is the one that kind of doesn't get picked up because it's no longer a rectangle or no longer a square. It's now kind of a trapezoidal, or what is that thingamajig called? So that's another kind of addition I put into the algorithm itself. When it comes to color, as you can see, not the entire lecture hall would be the same color. You know, sometimes you've got a light in between that'll affect the poll sheet that the person closest to the light kind of holds. And then sometimes there's bright light coming from outside, and this also affects kind of the color of the poll sheet when it's actually taken. So I also ran a kind of color dimming or brightening for all the poll sheets or the entire image itself, actually the template itself. Okay, and then I kind of ran this through a threshold to kind of match the template, and this is where that really the template matching comes into play. So once you run it, you kind of get your results, and yeah, that's where you kind of get, okay, this has been detected, this hasn't been. And this is really where it comes to the point of detection. So I think that's about 191 lines of code, including the lines where I manually put results in. And this is all up until the detection. But the next section is more a section on kind of figuring out, is this data correct? And if it's not, how far accurate is it? So sometimes you'll see 10 false positives. Is it a good system or is it not? Or you'll see a lot of positives and then 0 false positives. Yay, awesome. Then there's a couple of false negatives that might come into play. So you're really kind of trying to compute how best to measure the system. And this is where all this code kind of starts. So it kind of runs an entire section on just trying to find out if this system can actually be commerciable and how good is it a system or a audience response, can I call it system. And I think here is where I kind of print the true positives, and then I print the false positive, and then you kind of run through can I call it a formula to kind of find how precise is it as a computer vision system, and also what's the recall on it in terms of how many true positives over the true positives plus false negatives do you kind of get. So then you kind of compute it. So it's not just a matter of, oh, by the way, yay, we find some bounding boxes. Awesome. Okay, so that's really the kind of research I went. And then, yes, at the end, I kind of take a snap of how long it actually took to do this entire program. Generally, this program took quite a while. I think it takes about 5 minutes, which is not ideal. And one of the issues you can kind of bring in, or one of the things you can do to reduce this, is to reduce the number of transformations or even the color. So sometimes, as you can see, I commented out color to not go through the iterations of 40, 80, 120, but just whatever color it is. It just runs through it. Or rotation, instead of going through every 15 degrees, you're now looking at every 22 degrees in this sample. So it's kind of reducing the amount of time it takes, but at the same time, we want accurate data. So it's kind of a scale between which one do you want, accuracy or speed. And that's kind of the code involved in the program. Okay, so yeah, this is kind of what I showed you in the Wing IDE. And that kind of concludes my presentation. So we looked at the computer vision, we looked at audience response systems, we kind of look at the motivation, why should we even study this, why should we do it? And then we kind of looked at the code, and now it's kind of like the summary, and I'm not too sure if any of you have any questions or the like. But yeah, that's computer vision and color pole sheet kind of question. Okay, a couple of questions. Thank you very much. Okay.
Thanks, man. What
Sure.
were your results like? Your accuracy?
So out of a class of about 100 students, the accuracy was about 80%. And then out of, let's say, I think I did another class of about 50 students, the accuracy kind of rose because it's easier to kind of picture everyone. There were obviously a few guys that, they hold it bad, or you've got all these issues with color and lighting. So it's about 80% to about 90%.
What do you do if you've got an audience in several rows like this and the people at the back, their cards are hidden by the people in front?
So the one thing that we always did was, if you can see the screen, then it's best to bring the color pole sheet right in front of your face. So when it's time to actually take a picture, everyone put it in front of your face, then it's not hidden. Yeah. So that's the best kind of way to get it. If something is completely hidden, unfortunately, computer vision won't be able to pick it. As in, it's impossible, and that's where you kind of have your accuracy kind of dropping. Sure.
Speaking from a perspective of not a lot of knowledge about all this stuff,
Yes.
would it make sense to, instead of using, say, a solid color picture, use something that's similar to a VR, a virtual reality marker or an augmented reality marker, which should be relatively detectable if you can have separate markers for each indicator. That might give you a better false positive to result ratio.
Yes, it's actually a study that was actually done, and I think it was done in India, where they kind of used QR codes. And yeah, they actually used QR codes to kind of pick up, same thing, computer vision. This time they used like a video to actually pick up, guess what, can we be able to pick it up? And they kind of got similar results because of the issues with computer vision. Someone holding over a particular markup section or someone holding it differently. So yes, a solid color sometimes is easier because once you can kind of pick out, and the reason why we chose this solid color on a white background is it's kind of unique to a certain extent. So what you're doing is you're saying, I want the code to first pick up where it's white. So once it's white, it's kind of like, hey, by the way, something might be here. Now I want to see, is there a color in between? Now with something like QR codes, a little difficult as well. Same kind of issues you kind of get when it comes to using a solid color and yeah, using the QR codes, I guess. Yep. So you don't really escape that last 10 percentile in terms of the results. But yeah, you can kind of, it's another option, I can say. Yes? Oh, there's, yep.
Do you find that the polling itself affects the result? For example, you mentioned earlier that as the people hold up their cards, they can see the feedback.
Yes.
So let's say, for example, 70% of the people give one answer.
Yes.
And 30% of the people give another answer.
Yes.
So as they see that, won't the 30% that gives the other answer switch their answer to the one that the 70% gives?
So yes, I'm guessing it will affect, but when the question is asked, for example, like who invented Python? I saw a lot of people were kind of like, do I need to put up my hand or not, you know what I mean? And most of the time it's who invented Python. Okay, guys, camera's got a 5-minute delay. I'm switching it on. Are you going to put your poll sheets up? There are going to be people that are going to be like, hey, by the way, I just don't want to put it. Hence, I don't want to give feedback. But to those that actually put it up, yes, you can kind of see the person beside you. At the same time, you can either you're correct or he's wrong. Otherwise, you're going to, all the 30% is going to switch to the 70%, or the 70% is going to switch to the 30%. So, okay, I think,
No, but the problem here is
yes.
People in attendance will follow the majority.
That is very, very, very true.
So if you do not have feedback
Yes.
immediately, then they're kind of in the dark. But
Yes.
if they see the feedback as they give their answers, then a lot of them will switch to the majority answer.
Yes. So because this is not, can I call it a video, it's actually a picture. The picture is taken at a particular point when people have their cards raised. So if you change your answer before the picture is taken, yay. If you change your answer once the picture, whilst the picture is being taken, it's going to give whatever the picture is taken. So for example, if I ask this question now, how many people are over the age 30? Whatever you give, picture is taken, there's no changing after that. Then it kind of does the analysis in the background. And then it kind of says, oh, by the way, this is our demography. Now I can kind of engage with you with regards to the answers I've got, which is kind of a nice way where everyone's involved. And at the same time, you said, guess what? I think Tim Berners-Lee invented Python. And then you can kind of get feedback and say, hey, by the way, that's actually not the case. Then you learn in the session. By the time you move out of the session, you kind of have increased your knowledge. Okay?
Have you considered running your matching algorithm in parallel threads or offloading from a Raspberry Pi to a more powerful machine for a quicker response?
I haven't yet actually tried that. I think one of my supervisors actually thought about it. And it's really that question of we want it maintainable, we want it cheap, and then we want it fast. So you're now kind of weighing the options. Okay, if we want it cheap and we want it scalable to anyone everywhere, what do we do? Yes, we can run it in multiple threads, something that I should actually try. Or, we run it off the Raspberry Pi, it's just there in the center of the class. It takes the pictures, everyone's happy, people leave, people come back. Once it's something that's also running on your laptop, now every facilitator has to have some kind of a program where it runs. If it's on a database somewhere, then you've kind of got to have that link. So, but something definitely to try, and something I haven't investigated as yet. But yeah, it's a work in progress, can I say?
Yeah, I mean, if you host it on Amazon or something like that, you could get a response pretty quick.
Yeah, as in something definitely to try. Very good point on that one.
Sorry, I'm seeing lots and lots of hands, but we only have time for one more question. It's going to be right at the back there.
Hi. Sorry, could you go into more detail about why you didn't want to use the phones? Because to me, there seems like a lot of holes in the system. Whereas if you're using a phone and using like Wi-Fi or SMS and you get someone to sponsor the SMS or you do a Wi-Fi mesh or something, I do think that you can tackle the problem of people sending an anonymous answer. Yes. You can also get results immediately.
Yes.
So I'd like to know that a bit more, please.
Okay, so one of the things that one of the issues with regards to this research was we want to create something that is applicable to the rest of Africa. And yes, we're in South Africa, there's awesome Wi-Fi, everyone's got a smartphone, and technology is far and wide. But when you go into other areas of Africa where phones are not really accessible, what we definitely didn't want to do is exclude someone from the crowd. Because once I say, hey, by the way, everyone with an iPhone is the only one that can respond, then what happens is you've literally cut your response feedback by maybe half. And this is not even the case in Africa alone or South Africa alone, but throughout Africa, let's say to one of those other countries where smartphones are 1 out of 10, you don't kind of want to exclude people. So we kind of looked for what's the best tool to include everyone, not bring in higher costs for people, and at the same time get the kind of feedback we want. So that's why we kind of moved to this computer vision and Raspberry Pi kind of option.
Turn this on again. So I get what you're saying. It's just, I mean, I don't know like the use of mobile phones around Africa and where exactly you're picking your data up. I can understand if you're in some rural area, maybe no one even has like a simple Nokia.
Yes.
But I don't know, like to me, there seems like a lot of loopholes. There must be like an easier way to do this. It seems like there's a lot of problems. And I know that like if I'm sitting in an audience, I might not even put the colored paper up.
Yes. So
I'm going to have to ask that you guys take this one offline because it's probably time to close. Thanks from the absolute forest of hands. That was clearly a very interesting, provocative talk.
Awesome stuff.
Thanks very much. Another round of applause.
Right.